Here we go. So somebody walk me through. Okay, I want McGregor to get me to the point where we can figure out if we can solve this thing, and then I want Allie to get me to the solved point.
Alright.
Because you're not in your right seat. I would, but Paul's not here.
Source you want, minus 8.
Okay. We'll subtract 8 from both sides.
And then you should get 3, and then the thing, and then negative 2x plus 9 thing equals 1.
Equals 1.
No, sorry. Equals 3.
Okay.
Divided by 3 on this side. So Eddie, you get negative 2x plus 9 equals 1. Then, it's positive. You can do it.
I can do it. So before Anna asks me the quick question, I'd like to talk about what McGregor said. McGregor is exactly right. This is where we're at here. We can solve this thing. When we have this kind of a readability thing. This thing reads 3 times the absolute value of 2x minus 9. So instead of saying things, maybe fire with 3 times the absolute value of negative 2x plus 9. No, you did everything right, but I'd like you to expand your math vocabulary. And instead of saying 3 things, negative 2x plus 9 things.
No, I meant the line.
I know. So now I'm telling you how the absolute value sign.
3 absolute value.
So you should say 3 times the absolute value of negative 2x plus 9. It's the absolute value sign. Okay, that's your question. Okay, so McGregor said we can solve this. So Allie, tell us what we do to solve it. So we do negative 2x plus 9 equals 1, or negative 2x plus 9 equals negative 1. Mm-hmm. Okay. Okay. So I get x equals 4. Write everything by negative 2. So I get x equals 5. So I get x equals 4 or x equals 5. Right? C. Excellent. Thank you for your contributions. Love it.
Yay.
Video so I can yell at Anna and Lauren for talking while we're talking about math.
Wait,
should have left it on and posted on YouTube.
My video or my voice right now?
Probably. No. Don't lie to me. Alright. Might have been. So, here we go. So today we're talking about absolute value inequalities. So we're trading out the equal sign from yesterday and throwing in inequalities. So what I'd like to do, okay, so these numbers, negative 2, negative 1, 1, 2, 0, they're all relatively in the same area. Specifically, what area on the number line are they?
Close to 0.
They're close to 0. Nate?
There can be anything greater than negative 3 and anything less.
So, that sounded like you gave me an and inequality. You said it's anything greater than negative 3 and anything less than 3. So how would we graph this inequality then? How would we graph this inequality? How would we graph this inequality?
Well, you would do.
Lucas is kind of doing the motions. Lucas, huh?
Like this.
No, I want Lucas to tell me. Go sit down.
It's like that.
Go
Right?
sit down.
It's like that.
Go
Right?
sit down.
It's like that.
Lucas, tell me what you're saying. Okay? So where would you like your circles?
On 3 and negative.
So our critical values are negative 3 and 3. So we're going to want our circles at negative 3 and 3. Do we want an open or closed circle at negative 3 and 3? Okay. So the open circle means that we're not including our negative 3 and 3. So do we want to fill... So are we... And our closed circle means that we're including negative 3 and 3. So do we want to include negative 3 and 3? Will we want to include negative 3? You sure? Why are you not sure? Okay, so we don't want to include any of them because x can't equal negative 3 and x can't equal 3. So we don't include them. But then you did say that we want to draw the lines in between, right? You did say that. So yeah, that's how we graph our and inequality here. So that's how we would graph this absolute value inequality. So now let's do... So what do we notice about the numbers that we brainstormed, Nate? X is greater than 3 and less than negative 3? So you're saying all of those numbers up there are greater than negative 3? Or are greater than 3 and less than negative 3?
Not 4. Not any. No.
There is a huge difference between and and.
No, obviously
Wait, okay.
They have to be, the numbers can either be greater than 3, or they have to be 1.
Or x is less than negative 3. So there's a huge difference, right? Because 50 is certainly greater than 3. Yes, I can explain the difference. So, how do we graph this or inequality? Do we want open or closed circles at negative 3 and 3? Jordan. Okay. X, we know that x could possibly be greater than 3. So we start at 3. And which way do we go on the number line for greater than 3? To the right. So we draw an arrow to the right. Now, we also know that x could be less than negative 3. So we start at negative 3, and which way do we go for less than negative 3? To the left. So that's how you put it on the graph. So I want you to try. What did number 3 look like? Someone tell me what number 3 looks like. What did number 3 look like? Did we do number 3? Oh, Ben, good. Yeah, sure. Well, let's just do the number line. Close circles on negative 5 and 5. And then what? Okay? So let's think about which way to put it. What's your favorite number? 30. I'm asking Ben. 3. So if I plug 3 in for x, I get the absolute value of 3 is less than or equal to 5. Is that true? Yeah. So we want 3 to be included. So where does 3 fall in the number line? Between 5 and negative 5, right? So we're going to combine it. Right? So now, someone tell me what 4 looks like. Yeah, sure, I'll call you. So what's that look like on the number line? Good. Alright. We should have noticed some patterns here. We should have noticed some patterns. We have inequalities that have less than signs, and then we have inequalities that have greater than signs. So what did the inequalities with less than signs look like? They're connected. They look like and inequalities, right? Yeah. So you treat absolute value inequalities with less than signs. You treat these like and inequalities. And then what about the greater thans? What do these look like? Look like ors. So you treat these like or inequalities. Okay? I'm going to give you a mnemonic device to remember this by. Ready? For the less thans, remember land. So the L stands for less than, and the and stands for and. So for less than inequalities, treat them like and. For greater thans, remember org. For or inequalities, treat them like greater than. Land org. Land org. Nate. Tell you later. Yeah, I'll tell you later. Yeah. Absolutely. When you divide by a negative number or multiply by a negative number, still applies. All rules still apply. So, let's talk about A. So, in letter A, we have a less than sign here. So, what should we treat this as? Land org. Treat it like an and. So here's how I'm going to write this thing. So you can write, so first of all you can write it as, I'm going to use the margins here. You can write this as x minus 4 is less than 7 and negative 7 is less than x minus 4. That's one way to write it. Another way to write it, which is the way that I suggest you write it, is negative 7 is less than x minus 4, x minus 4, which is less than 7. You treat so this is how you would treat this like an and inequality. Put the thing in the absolute value signs in the middle. What's on the other side of the inequality on the right, and then its opposite on the left. And then solve, just like you normally would. Mitch. It's just supposed to be, I accidentally put a less than sign, but it should be a minus sign. So, Nate. In a minute. So I'm going to add 4. Something I noticed on your quizzes is when you added 4, you only added it to one of the other sides. You need to make sure you add it to all sides. So you should get negative 3 is less than x, which is less than 11. And that's your answer. And you could graph this if I asked you to graph this, right?
Yes,
I'm not going to ask you to graph it, but I know that you can. Nate. Okay, we're getting there. So now B is a little trickier. So pay attention to how you're going to need to write this. So you take what's in the absolute value, you take the sign, and you take the other number. So 2x is greater than 8. Or 2x, this is where it gets tricky, you change the inequality sign and you make the number negative. It's and if there's a less than sign, it's or if there's a greater than sign. And then when you get to this point, you solve just like you normally would. You divide by 2, divide by 2, and you get x is greater than or equal to 4, or x is less than or equal to negative 4. Ben. Because, remember, why can't we just put 2x in the middle and do this thing? Because, remember, if you flip over to the other side here, when you have a greater than or equal to sign, you treat these like ors. Treat them like ors. Nate. Yeah, sure, take a stab at C, Nate. Mm-hmm. So, what I want you to do is I want you to just go to E, scribble out the inequality, and make that a less than. So, rephrasing what Nate just said. We've got these absolute value signs, and we've got a negative number on the other side of the inequality. Whatever I plug in for x, what am I going to get on my left side here? No matter what I plug in for x, what am I going to get? Can I get 0? I could. So I'm going to get a non-negative number. I'm never going to get a negative number on this left side. So if I have, I'm going to have a non-negative number is greater than a negative number. Is that always true? Yeah. Positive numbers are always greater than negative numbers. 0 is always greater than negative numbers. So anytime you have absolute value is greater than a negative number, you have all real solutions. Okay. Now what about for E? On my left side, I'm always going to have 0 or a positive number. Remember, I crossed out the sign and changed it to a less than. So can this inequality ever be true? This inequality can never be true. So I can show you the other option here when you have negative numbers. So, why can't this be true? Because no matter what I plug in for x on this side, once I do all these operations and then have an absolute value, it's either going to come out as 0 or it's going to come out as a positive number. So 0 is never less than negative 23, right? Or any positive number is never less than negative 23. So this inequality is never going to be a true statement. It's always going to be false. So in this case, when you have absolute value less than a negative number, there are going to be no real solutions.
And it's not like that for C because that's just basically a real.
It's a greater than sign, a negative.
So that will always equal a positive number.
Good. So a positive number is always going to be on the left side, or 0. If you plug 5 in for x, you get 0. But you're always going to get true. If you plug in -2, -2 minus 5 is -7. The absolute value of -7 is what? 7. So 7 is greater than negative. Was that your question, Mitch? Okay. Kind of sticky, right? Kind of sticky. Yeah. Kind of here. So D and F are very similar, so I'm just going to ask you to do F. So F, let's decide, will this have a solution? Yes. So Mitch, how am I going to set this thing up?
Negative 25 is less than or equal to negative 4x plus 1, which is less than 4 equals to 25.
Excellent. So Mitch saw that this is a less than sign in the original inequality. So we treat this like an and inequality. So now I'm going to subtract 1 on all sides, not just my favorite side, but all sides. So I get negative 26 is less than negative 4x, which is less than 24. So now I divide by negative 4, right? So I divide by negative 4, right? So what do I get out?
Wait, that's not what it is. Why was
So I get 26 over 4, which is 13 over 2. What should my sign be? Less than or equal to?
Is it still negative 3 greater over 2?
Well, negative 26 divided by negative 4 makes it a positive. Greater than or equal to, because I need to change the sign, because I'm dividing by negative. X, which is greater than or equal to negative 6. Questions on F? Guys, put your phones away, please. So what do you think you do with these? 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 Gotta shake the rust out of this thing. Right here. It's actually Riley. No, it picked Ethan the first time, and Ethan's not here. Riley, what do you think I do with these? With letter A, what do I do with it?
Divide 9.
Divide 9. I'm left with x minus 7 is greater than or equal to 29 over 9. Will we have a solution with this thing? Yes. So what should I treat this as? A less than, I'm sorry, an and or an or? Or. So what should I write? Riley. Okay. X minus 7
Is
greater than or equal to 29 over 9. Good. Or x minus 7 Okay? Over 9. Okay. So, everything you said was great,
You didn't make the,
except, right,
Wait, I said
less than or equal to. Yes. So, first you write the stuff that's inside the inequality is greater than or equal to the number on the other side, or x minus 7. Change the sign, make it negative. Now, solve these the way you would normally solve them. Add 7. So I get x equals, if you remember from yesterday, this is the same thing, not x equals. X is greater than or equal to 7 plus 29 over 9, but 7 is the same thing as 63 over 9 plus 29 over 9. Or x is less than or equal to 63 over 9 minus 29 over 9. So I get x is greater than or equal to 63 plus 29 is 92 over 9. Or x is less than or equal to 34 over 9. So let's talk about b real fast. So first I need to subtract 3, right?
Yeah.
So I'm left with absolute value of 3x minus 8 is less than or equal to 1. So this is a less than or equal to. So what should we treat this as? And or?
What? Oh, no. It's less
And.
than
Land. Less than. And. So what we do is we take this number, make it negative, and then we keep this sign, keep it, write 3x minus 8, then keep the sign again, and then write that number. Okay? Riley. So, now, we can solve this the way we normally would. Add 8 to both sides. All sides, rather. So you get 7 is less than or equal to 3x, which is less than or equal to 9. Divide by 3. So you get 7/3 is less than or equal to x, which is less than or equal to 3. We go over D and then give you your homework. So I need to just do it because we're running low on time. Sorry. So here we go. First I'm going to subtract 2. Guys, I don't want to talk over you. This will go a lot faster and then you can go to lunch if I don't talk over you. So I get negative 6 times the absolute value of negative 8 plus 7x is greater than negative 42. Divide by negative 6. Since I'm dividing by a negative number on both sides, you need to make sure to flip the sign. So I get negative 8 plus 7x is greater than, nope, is less than 7. So we flip the sign. So now we evaluate. We need to treat this like an and because we got a less than. So if negative 7 is less than negative 8 plus 7x is less than 7. Add 8 to all sides. So you get 1 is less than 7x, which is less than 15. Divide by 7 on all sides. So you get 1/7 is less than x is less than 15 over 7. Ta-da!